In this lesson on evaluating absolute value, recall what the definition of absolute value is. And by definition, it's the distance from zero on the number line. We're going to look at a couple of definitions and ways of expressing in this class. So remember what happens if x is a positive number. Okay, so if x is greater than or equal to 0, then the absolute value of x doesn't change it at all. It's still the same value, so we can just drop the absolute value bars and we're left with x. If x is a negative number, remember what happens. Remember that a negative number becomes its opposite, which is the positive number. So really the absolute value of x in that case is equal to negative x. Examples A and B here will explain both of those situations. So A is positive, it's greater than 0. We've got the absolute value of 7, which is 7. We can just drop the absolute value signs. In B here, we're doing the absolute value of negative 1/3. So that's because it's less than 0, we actually have to change the sign on it. So you can think of it, if you want to think of it as putting a negative in front of it, you could think of that as negative 1/3. But a negative of a negative, remember, then is a positive 1/3. So we can just remove the negative sign. So it's the opposite. It's additive inverse. So if you see the expressions below that in these other instances here, we can use that in order to express those as exact values. So we're not going to pull out a calculator and calculate what the square root of 5 minus 2 is, because that will give us a rounded value. To keep it as an exact value, it will still be an expression, but we can drop the absolute value signs. So in this case, the square root of 5 minus 2, the question to ask is that value greater than 0 or less than 0? So if you think about the square root of 5, it's going to be a little more than 2, since the square root of 4 is 2. So it's going to be a little bit more than 2. So something a little bit more than 2 minus 2 is going to be positive, greater than 0. So we can just drop the absolute value symbols. And the absolute value of root 5 minus 2 will be root 5 minus 2. D, on the other hand, we've got 1 minus pi in our absolute value symbols here. So that's 1 minus 3 point something. That's going to give us a negative value. So we need to change the sign on it. So there's a couple of ways to do that. The easiest way is just to change the sign on each of the terms that are in the absolute value. So that would become negative 1 plus pi. So the pi becomes positive, the 1 becomes negative. And often we don't like starting an expression with a negative, so we might reverse those and change that to pi minus 1. Okay, so because this value is less than 0, we change the signs when we take the absolute value off. E is kind of tricky. It's more abstract, but we're looking at x being less than 0. X is a negative number. So what happens when we get the absolute value of x divided by x? Well, just look at the definition above. If x is less than 0, the absolute value of x is negative x. And we still have that over x. So when I have negative x divided by x, that's going to be equal to negative 1. And then let's look at the last two examples. I think they're the last two examples. So last three examples. Pi minus 3, positive or negative? That's 3 point something minus 3. That's going to be positive. So I can just remove the absolute value symbols. Negative 6 plus 3 point something will still be negative, right? So since it's going to be negative, we change the sign on both parts. So that becomes positive 6 minus pi. And then h, the absolute value of 6 plus pi, because those are both positives. When we add it, will be positive, so that will just stay the same. So we end up with 6 plus pi. And that's evaluating absolute value expressions. absolute value can also be used to find the distance between 2 points on a number line. So the distance between two things is also like describing the difference between two things. And we always find the difference by subtraction. So if you think about the difference or the distance between 15 and 7, you can say, well, that would be 15 minus 7, which is 8. But you could also say, well, what if I reverse that? Because it doesn't say you have to do the larger, subtract the smaller. What if I did 7 minus 15? I would get negative 8. So just by putting an absolute value around both of these, I'll get a positive distance for both of those expressions, which makes a lot of sense. So the distance between 15 and 7 could be described as the absolute value of 15 minus 7, or the absolute value of 7 minus 15. Then it doesn't matter which order we do the subtraction in. So here is our definition. If A and B are any two numbers on a number line, the distance between A and B is given by the absolute value of A minus B, or the absolute value of B minus A. Either way, we'll get a positive result. And in this definition, notice it does not say that A is larger than B or B is larger than A. It doesn't matter which order that's done in. So a little example of that would be, what's the distance from negative 7 to 3? So we can do it two ways. We can say the absolute value of negative 7 minus 3, which gives us the absolute value of negative 10, which is 10. Or we could say, well, what's the absolute value of 3 minus negative 7? Well, that becomes 3 plus 7, which is the absolute value of 10, which is 10. Both ways we get the same result. So either number first, because we're using absolute values, gives us the same result. And that's the end of that lesson.